Welcome to Basic Differential Equations Vocabulary. So we briefly saw differential equations in our previous videos, but essentially a differential equation is an equation that contains one or more derivatives of an unknown function. So for a couple examples, we could have y prime plus x squared y is equal to 0. For another example, we could have y prime or y double prime, second derivative, plus 4y prime minus 5y is equal to 2t. So both of these are equations that involve derivatives of the unknown function y equals y of x or y equals y of t. The order of a differential equation is the order of the highest derivative in the equation. So if we take the two equations we used before, y prime plus x squared y equals 0. The highest derivative is the first derivative. So the highest derivative or derivative is y prime, which is first order, and so this is a first order equation. Versus for our second example, y double prime equaling 4y prime minus 5y equaling 2t. The highest, oops, this should have been a plus, not an equals. In this case, y double prime is our highest order derivative. So this is a second order differential equation. An ordinary differential equation is what we'll be starting the semester off with. An ordinary differential equation involves the function in one variable. So both of the examples we have seen so far are ordinary differential equations. So our y prime plus x squared y equals 0 is an ordinary differential equation, as is y double prime plus 4y prime. Don't need a second derivative there. Minus 5y equaling 2t. Sorry about that. Next up, we have partial differential equation. So a partial differential equation involves partial derivatives of of a function in more than one variable. So we might have something like mx minus my is equal to 0. Right? So here we have a function in x and y, presumably, and we take the partial derivative with respect to x and the partial derivative with respect to y. A solution to a differential equation is a function that satisfies the differential equation on some open interval. We will see more, we will see specific solutions in the upcoming videos. Solution curve is simply the graph of a solution. To a differential equation. And then last up, we have an integral curve. So an integral curve is such that every function y equals f of x, whose graph is a segment of the curve, is a solution to the differential equation. So essentially, we may have a curve which is not a function, right, that doesn't satisfy the vertical line test, but for which sort of every point in open interval along that curve, or almost every point except where it's vertical, right, such that basically everywhere is going to be a solution to that differential equation. So the example that your textbook uses is if we take just a standard circle, x squared plus y squared equals r squared, for whatever r is, this is a solution to y prime equaling, sorry, is an integral curve. To y prime equals negative x over y. So x squared plus y squared equals r squared is a circle that's not a function. So we would need to split it essentially into the two pieces. So if we split this as, so note x squared plus y squared equals r squared is not a function. But we can split it into two functions. Sorry, my computer is not updating. A moment. Okay. So we had x squared plus y squared equals r squared is not a function, but we can describe it with two pieces. But it can be described with two functions. The top half of the circle would be y equals the square root of r squared minus x squared. And the bottom half would be y equals negative the square root of r squared minus x squared. And it turns out that both of these pieces are solutions to y prime equals negative x over y. So these are both solutions to y prime equals negative x over y. So that is sort of what an integral curve is referring to. It can't itself be considered a function necessarily, or it can't be considered a solution function because it's not a function, but each of the pieces of it are solutions. So there is your basic vocabulary. In the next videos, we will check for solutions and solve some very basic differential equations.